So today we are here with a new problem, and the problem is binary tree pruning. So let's understand this problem and see how we can solve it. So in the given problem we have a root of a binary tree and we have to return the same tree with removal of all those subtree which is not containing the 1. And also if there is a node which is not containing 1 but that node is a descendant of any other node which containing 1, then we don't have to remove it. Let's understand this. So in this given example, if I try to prune this, and if you see this node, you can find that this 0 can be removed because this 0 is not lie inside any other 1. So its parent is 1, but there is no child as such which contains 1. So this is one subtree that we can remove because it is not containing 1. So we can remove this. But if we see this 0 subtree, so this is linked with another subtree which containing 1. So if we remove this, if we try to remove this, it basically break this link. So we can't do this, okay? And in this case our answer is this type of binary tree. I hope the problem is clear. If not, let's take this example. Now you can see that if we see this, then this 0 can be removed, this 0 can be removed, this and this, because none of these node is linked with any other node which contains 1 as its child, and thus we are able to remove all of these, and in this case our answer is this type of binary tree. Now let's see how we can solve it. If you see this very closely, you can find a very good pattern here. What type of pattern? So if you see all these nodes, you can find that the node which is a leaf node is always removed. Why? Because if we talk about a leaf node, that leaf node doesn't have any child, and if it is 0 or if it is something which is not equal to 1, then we can easily remove it without thinking whether it is a descendant or not. And this is the only concept, only thing we need to understand to solve this problem. Let's see how we can do this. So let's suppose if we are at the root node and we will check whether it is 0 or not. So you can see it is not a 0, it is equal to 1, so we can't remove this. We move to left and check again, it is 0, but you can see this is not a leaf node, right? We only have to remove leaf node, so we can't remove this. We can go to left, it is 0 and it is a leaf node, we can remove this, and now we can go back to this and we can go back to right side, and this is 0 and also leaf node, we can remove it. Similarly, when we come back, now this is 0 and it is a leaf node because both these two nodes are removed, and thus we can also remove this. When we come back, we traverse to right, then we traverse to left, it is a leaf node, we can remove this, and at the end of the day we come back from this side, we go, this is not that, and this is the only thing which is remaining, that is what I return. Now let's see the case where we have things like that. Let me build this. Let's suppose the root node is 0, this is 0, and this is also 0. In that same case, when we are at the root, we go to left, this is a leaf node at 0, we can remove it. We return back, we go to right, this is leaf node and 0, we can remove it. When we return from this, at this point of time we also have to check whether this node becomes the root node or not, because it happens when we try to prune the binary tree, the parent node which we traversed before can become leaf node again. So we will again check whether it is a 0 and a leaf node. If it is, we also have to remove it and we have to return none from this. I hope you are able to understand this problem. Let's see the solution, then it makes more sense to you. So we are doing the same thing. First, this is a very base case that if I'm sorry about this. So if the root is none, we have to simply return none. In other case, if the value is 0 or not equal to 1 and that root is a leaf node, then we can simply return none as we discussed. And similarly, we call to the left side, we call to the right side, and we are break that link by pruning. So that is what we are doing here, pruning. And when we come back, I am talking about this case. Let's suppose we remove this node, we remove this node, and when we come back to this one, we will again check whether the root is 0 and it is leaf. Yes, if it is a leaf, we have to return none. Other than that, we can simply return root. And that's how we are able to solve this problem. I hope you like this. If there is any doubt, you can please comment out and mention any problem. Thank you.